All right. Hello, NDC. Oh, just a couple more people coming in. Yeah. Isn't it awesome that the lighting matches the slide? Because it would have been really, really unfortunate if the lighting was all green and we're starting with that one. So you having an awesome day? Yep. I'm Nick. I'm sure I met some of you through my earlier work on AutoFact, maybe, or through the time I spent on the BCL. Currently, I work on a product called Seek, but this session is about an open source project that I started and now run called Serilog. And it's a 60-minute session, so we should have heaps of time at the end for some questions if you've got any. And if not, we run over. I'll stick around and make sure that I have a chance to talk to you. So don't worry too much if you think you miss any of those. So anyway, I've come all the way out from Brisbane on the east coast of Australia. So it's a little city like Oslo. Probably like Oslo, we've got a rather big software scene, especially a .NET scene for our size. Unlike Oslo, we have beautiful sunny weather just about year-round. It's great that the wildlife loves it. This story starts some years ago when I'd just come back from overseas and I was working on a system for a financial institution, and I think it was really the kind of system that financial institutions the world over write. This one was taking payments from customers through a portal on the internet. I just finished a really long, arduous, unpleasant session of debugging, trawling through log files. And that wasn't the kickoff for this, but I realized while I was doing this just how much interesting data we keep in application logs. I was a consultant, and so I saw the opportunity to really pull some of that out and whip up a report for my client. I thought I'd impress them, sort of giving them a bit of insight into their system. And I spent 5 minutes thinking about how I might do it, kind of put the pieces together in my head of how I'd write some regex and all the rest of this kind of ugly gunk, and then I had to shelve it because I realized there was just no way I could justify taking that amount of time out of the project that we were working on to do anything with this data that we were collecting. And that was really disappointing. And so it sort of stuck with me that there was this missed opportunity. And so now we are down the track. The product of that sort of process was Serilog, which is an open source project, as I mentioned. It's a few years old now, and it's gone beyond being a kind of a pet project. The core contribution sort of team is quite dedicated. We've got 80 contributors listed on our main repo, but if you look at all of the 209 repositories in the Serilog organization, I think we've got, all of the 59 repositories in the Serilog organization, we've got about 209 contributors now. In the NuGet scheme of things, I don't know if it's huge, but we have about 2.5 million package downloads. And it's kind of interesting just from the perspective of it being a new logging library that's come into an already pretty established space. Like I've always used Log4Net for application diagnostics. I know lots of people love nlog as well. Those are really established libraries, and so it's quite hard to believe that there could be interest and activity around building a whole new logging framework now that .NET's more than 10 years old. But we do have there is a lot going on with Serilog. I really want to try to get to the core of that today in this talk. So I'm not going to spend a whole lot of time going over the details of how the Serilog API works. One of the design goals when Serilog was originally built was to be completely unsurprising. If you can take in what's on this slide, like Serilog was developed fairly recently, so it's all quite a modern API with code as configuration. It's async aware. It was born into the kind of world of tasks and all the rest of that. You can write to log files. You can write to the console. I think you saw on the last slide that there are about 100 different sinks, so destinations that you can send log data to. None of that particularly distinguishes Serilog from as something different. You see, it's a leveled logging library, so you can write debug statements or information statements or log your errors and control at runtime which ones of those are actually going to be written through to storage. Yeah, if you take that in, you've pretty much got most of the details now of Serilog. So in this session, what I really wanted to spend some time on is the core of the ideas that make Serilog different, and I think interesting at this point in time. So those are capturing events with message templates. So this is how Serilog takes information from your program and records it so that later on you can do diagnostics in a low friction kind of way. And the second piece that we'll look at is related to it, which is doing correlation through event enrichment. So this is, I guess, how you use Serilog to find that needle in the haystack when you're actually doing some diagnostics for an application. All right. So, and part one, we'll look at the message templates part. Excuse me. Has anyone heard of message templates previously? Cool. Anybody using Serilog? Oh, lots of hands. Cool. Aha. Anyone never heard of Serilog? Apart from, I guess, seeing the title of this session. Yeah. Yeah. Okay. So it turns out that there's kind of a long history in application logging. Certainly, a lot of people have thought about how to improve this situation that we have. The classic kind of most established form of logging that we have is text logging, which you'll have seen with Log4net, where logging is done by creating a kind of a narrative of what's going on inside the application, usually it's sometimes called printf debugging because of the formatting functions in C. Very old approach. You can see the example on the left where we take an elapsed time span and we format it into a string and we write that out to the console. So there's some real strengths that in text logging in that it's very easy to write a quick logging statement as you work through writing a piece of code, program code, and you don't really have to take your mind off of the job. You can just kind of write out your thoughts and, well, this is what I'm intending this piece of code to do, and in goes some data and it comes out in a kind of a nicely human readable form. So when you scan through a text log as a human, I mean, all of those, all that perceptual system that's trained for reading text can really quickly make a narrative out of what's going on in a text log. The problem with text logs and why we're here, I guess, is that humans and computers differ a lot around this point. Like processing this text to say find all of the events where the commit took longer than 500 milliseconds is trivial to express in English, but quite a painful process to go through if you want to use some kind of automated tool to pull that out of a log, especially when there's a lot of data and all kinds of different information formatted into it. So on the other side, we have a school of thought that's called structured logging, and this has origins way back. And the approach that structured logging takes is to conceive, to refocus this idea of writing logs not as producing messages, but as producing events. Which in this case you can see my fake structured logging API. We're just using an object initializer to create an anonymous type that has exactly the same data. We've got the type of events the type of event that's occurring, and then the elapsed time. And you can imagine that when we produce something like a stream of JSON out of this style of logging, it's trivially easy to use the kinds of tools that we have to go and find events that are commits, or to find events that where the commit time took between 500 and 600 milliseconds. It's much easier to mechanically work with this sort of information. Unfortunately, though, we've now swung the other way, and we can't use that human text recognition kind of system to make sense of these logs really quickly. So during development, not only do you have to kind of switch modes and think about how to structure up some kind of object to represent your event when you're writing code, which introduces friction, it's also very difficult to scan a stream of JSON that's more than 5 lines long and make any sense whatsoever of what's going on in there. So structured logging has been the underdog for a really long time. It's fantastic in dealing with large volumes of data from very busy systems, but the ergonomics have been very poor, and so it hasn't really achieved the traction that text logging still has, I think, with developers. But I guess the question then that we have to ask is, we're stuck at a local maximum here where we've got good ergonomics at development time, where obviously resources are pretty scarce. And then when we're desperate to get information out at runtime, there are techniques that suffice. But if we take a closer look at what we're doing with text logging, is there a way to remove all of this manual effort and still keep the things that we like about logging with text? So when we write a text logging statement in an application, we do actually have a separate schema which describes what the event is and data that parameterizes it. So when you're writing a program and your program's running, we've got that format string, commit took curly bracket 0 milliseconds, and we've got elapsed as a separate property. When we format that through into text, we just lose that information that we had, and we think we're sort of throwing it away. It's a lossy transform, and there's not really any easy mechanical way to go back from that log line to the original kind of separate schema and data, which is really where the problem comes into it. But if we were able to preserve those two pieces of information through our logging system, could we have our cake and eat it too? And that is, I guess, one of the core premises of Serilog. So here we've got an example written with Serilog. You notice the logger isn't initialized in the using statement. Serilog's built with no static state in the logging pipeline at all, so you can create yourself 100 loggers, call them from any thread you like, whatever you like, or as a convenience, if you don't want to inject loggers or pass loggers through your code, you can use the static log class, which is what I've used in this example. So here we have, any great idea in programming really has to be expressible in a console app, or it's just too much for me to take in, right? So we've got a console app. It says hello. And if we run it, two pieces of information there. Oh, if we run it with Control F5, there's two pieces of information there. I hope that the text isn't too small for you. We've got the counter that's going through the stream of messages, and we've got a name. And you can already tell that Serilog is a little different from what you're used to in text logging, and that it's maybe a throwback to Visual Studio 6.0, I think, the magenta for numbers and the green for strings, something way back in the past anyway. But you can see that when Serilog's printed that message out to the console, it has more awareness than what you'd typically expect in a logging library or in string formatting. So it has enough information there to know that the number is actually numeric and it's separate from the message, and the string is also a separate piece of data there. And if you can kind of wrap your head around what's going on there, you've got the fundamentals of how Serilog combines text and structured logging. To see that more clearly, though, we'll switch over, and instead of viewing that as text, we'll take the same code and we'll write it out as a JSON stream. Unfortunately, the readability just goes downhill. However, you notice that the template, the hello number, and then the format placeholders is in that JSON document, as well as the individual values. That we've got a 0 for the counter value, and we've got 1 for the name. I mean, I can't remember that 0 is the counter and 1 is the name, and I've got one logging statement, so that's obviously not going to scale to a big, complicated application. So Serilog introduces an extension to .NET format strings that we call message templates. Whoop. Page down and the arrow key next to each other. Okay, and so now we'll just make a slight change, and you see instead of using numeric placeholders in that format string, there are now two placeholders that are named. We have the counter and we have the name, and both of those are essentially going to become properties on the log event that we're going to collect to do analysis on later. Whoop. Function is next to control. So the template is carried through again, but you notice on the right-hand side the two properties that are included in every log event are named now counter and name, which means that even though we can take this same piece of logging code and produce a stream of like machine toolable JSON, we can just as easily continue to to produce the human readable text at the same time. It wouldn't really be super interesting though if all we were doing was producing a stream of JSON. Obviously there's, I don't want to go and parse and read JSON log files. Serilog came along, I guess, at the point that most large .NET systems were not monolithic anymore, and so it's kind of post-log file, if you can imagine that. And Serilog is built so that the target for log events is generally expected to be something that's JSON aware or something that can represent structured data. If we take the same example now, and then we pop this into Postgres, which I just noticed there's a Postgres session going on in the room next door. So Postgres is quite an interesting database for storing event data because it has a very rich system for including JSON inside a table schema. So you can have a JSON column, and it provides indexing over the JSON. Partial indexes and a few other concepts make Postgres really interesting to store events in. If we take the same code and we run that, you see we get the output on the console, but as well, we've written the same event information to a logs. That's not good. Thank you. So now you can tell that I didn't just pre-bake the content of the logs table. It really is empty. Yeah. Yeah. All right. So if we look in our logs table, you see that we've got a properties column over there on the right that has much the same as what our JSON documents at the console showed. And in that little stream of messages, we've got the name, we've got the counter, and they're both preserved. So if you think about the example we were talking about with the elapsed timings, if we want to find all of the events from an application now where the counter is, say, greater than 7, we can, we can use Postgres' JSON query syntax and go through there, and you see the properties, and then a very complex looking right arrow that's accessing a JSON object member, and then Postgres needs to quote JSON values in strings, but that's actually doing a numeric comparison. And if we run the same query now, we've zoomed in to just the events where the counter was greater than 7. Now, it seems simple, but of course, we've just taken a log stream from an application, and with no extra work at the time that we wrote the logs, we have it in a format where we can pretty much perform any arbitrary query on the events that come out of that application. So when time comes to actually do some debugging and diagnostics, or even just to try to get some insights about the system, the amount of effort that's actually required to go and extract that information is hugely reduced. So previously we had sort of text logging was easy during development time, and structured logging was better for analysis. And now with Serilog, we've got the case where hopefully we can still enjoy really simple text-based kind of logging for development, but then by sort of flicking a switch and sending the logs to somewhere that's more suited for production diagnostics, we can actually get the full structured data experience out of that as well. So there are a number of places that you can send logs from Serilog. Actually, we've had the number already. It's about 100, which is pretty amazing, I think, because I wouldn't have ever imagined that people would have such a huge variety of logging targets. Obviously, the space has become really hot in recent years, and so we've got application insights from Microsoft, and we've got Splunk and Elasticsearch, and we've got Postgres coming along quietly in the background, adding all sorts of awesome JSON querying facilities. I'll show you another example using a log-specific data store called Seek, which is what I work on day to day, and it's good for these kinds of like it's good for demos because I can run it locally and I don't have to worry about the network causing some pain. So if we zip in there now, did I just do that startup project thing again? No, I didn't. There we go. Some serious horn tooting going on out there. So most of the time with Serilog, you won't generally save yeah, you won't generally save events locally because you're running right-sized services or some kind of cloud-based service that needs to draw events from a whole host of machines. And so most of those 100 targets, I think, for Serilog are network-based. This one we've just sent the logs via HTTP to a server running locally. And again, sorry, seems like. And again, I've proven that there wasn't really any preloaded data again. And you see that the counter and the name popped through, and we've got a query interface where we can do things like query counter is greater than 7 and get a result back from our log events, and we still get the text view to read. But the promise of Serilog is also that Serilog would provide fully structured events. So coming up against something that's built for, say, just recording pure JSON objects, there's a lot more opportunity to record interesting data in JSON. So JSON has a basic type system, but it covers arrays and fully structured and nested objects. So Serilog needs to provide that kind of experience too, to really... Excuse me, I'll just wait for the car to finish tooting its horn again. Sorry?
The Russians are coming.
All right, so for Serilog to record structured data, there's a little extension. Oh, alarm system test, thank you, yep, okay, great. So here we've got a more interesting user object, ID equals 3. And to record that with Serilog, there's an extension of message templates that instead we could pass the user through. And you get an idea of how Serilog got its name. It's a serializing logger. And so it's not limited to just having simple values recorded like strings and numbers. To send data through Serilog that has structure, you can include it in your log event and pop a little prefix in there, the @ symbol, and then if we run that again, hopefully startup project is set this time, and zip over and have a look at the resulting data. You see that instead of the user coming through with toString, we got the user through as a JSON object with properties, so we can look for user.id equals 3, and obviously we've only got one user here. And that's really really useful and powerful when you're doing things like recording, say, headers from an HTTP request or DTOs in a system. You also do need to be very careful, though, because I think the first thing that people tend to do when they start logging with Serilog is serialize all the things. And initially we had some really interesting bug reports where someone would have serialized an object that wasn't built for serialization, and it had a system.type in there. And so you walk from type to assembly, and then you walk from assembly to all the types in the assembly, and then all their dependencies and all the other assemblies, and end up with gigabytes stashed into just one little log message. So hence, serialization with Serilog is an opt-in with that little sigil character there. And you do need to still kind of keep in mind that log events should probably be pretty compact. But especially if you're trying to debug a problem with a system that is networked and you have say a request object coming in, being able to log all of that data and then query it for, say, I want checkout requests where the cart has more than 5 items, makes Serilog a really different logging experience to what you can achieve with text. So that's the essence of message templates, and it is a very simple idea, but it's the possibilities are really quite deep. When I first realized how much more valuable you could make your log data with so little extra effort, I sort of went along to a user group talk and jumped up and said, this is going to be the next big thing. And that was probably 3 years ago. And I don't think I was too wrong, because in the recent versions of ASP.NET Core, message templates have been adopted into the logging infrastructure there. And for instance, if you look at the logging output produced by ASP.NET Core MVC, you'll see that it's using message templates to record web requests and searching for controllers and all those things as well. So this is from messagetemplates.org, because the slide that we're looking at, because we realized, I think, when that process began, that there are actually quite a few libraries now adopting message templates in .NET in addition to Serilog. So even if you don't go and adopt Serilog, hopefully this is something that you can apply either now or in the future with one of the other libraries that you might be using. So message templates separate out the capturing of a log event from the rendering. It's a really simple idea. I didn't realize myself when I started working with them, but there's one other little side benefit that's quite surprising that you don't initially see, but becomes obvious when it's pointed out. All of the events produced from a single message template are effectively the same event. And their type is really the template. Every event that's produced by the same log line will have the same template associated with it. And if you imagine that, for instance, you're looking for cart checkout events and you're logging all of those with the same template like that, being able to go and actually zoom in on all of the checkouts just by searching for events from the template is really powerful. If you have to collect the template as well as the rendered message, though, you've essentially doubled the volume of the log data that you have to collect. And so it's more common when using Serilog to instead record the message template by hashing it. In this example, the message template gets hashed and produces that first value that's highlighted, and you see that all instances of the same event produce the same computational hash from the message template, and then the different event gets a different hash. So that's something that I didn't expect was going to come out of message templates when I first started working with them. However, it's become a kind of a very natural way to go and search for log data now. And so you can see in this case, even though all of the events look different and they have different data embedded in them and they can be very complex, it's trivial to go and zoom in and capture just the ones that were produced from the same log line. But that is not, I think, the thing that makes me really excited about event types. Like, most diagnostic sessions do start with looking for a known thing. I've got an exception. It was raised in a web request. I see the order ID in that web request, and then I want to zoom in and find all of the events with that order ID, and I'll see something that went wrong. Like, that's a pretty common diagnostic scenario. But the ones that really make me sweat are the unknown unknowns. When something went wrong between 2 o'clock and 3 o'clock yesterday afternoon, and our numbers are out, and no one has any idea why, and I have a million log events to get through to figure it out. But the curious thing is that just like, I guess, instances in C# itself, you generally have a lot more instances than you do types. And so if we start excluding the events by their template, so these are the ones that are, and maybe we exclude the debug events so that saves us a bit of zooming. But so, okay, it's got nothing to do with claim status, so we're excluding that. It's got nothing to do with this eligibility thing. Exclude that. Not interested in this one either. And while we might have a million events to scan through, after we start to exclude them type by type, things that we would never have actually found, things that we would never have found scanning a log file by eye, because we don't know what we're looking for, suddenly can be revealed. And that's probably, to me, the number one reason that I really enjoy using Serilog for this sort of work. Okay. So Serilog out of the box doesn't actually provide event types, by the way. You need to plug that in. And we'll see actually how that's plugged in a little bit later. I've found that a 32-bit hash seems to work. I've never had anybody report collisions, but you can also actually take that hash and just format it into a log file and get some of these benefits too. Like, you might still have a text log. You might not have any central way to collect it and search it as structured data, but that doesn't mean that you can't find some kind of way to encode that event type down into the log file and make just text-based log debugging a lot more fun as well. So it's not only for kind of structured log data collection. So that's event IDs. So that's pretty much message templates in a nutshell, and why I would use Serilog. But the other interesting thing that Serilog brings to the table, while it's otherwise unsurprising and looks just like Log4net that you know and love, is it really does have a very, very strong focus on treating log events as events. And I say correlation, but I had to pop this up because if you were around through the time of doing SOA with WCF and those sorts of tools, the notion of correlation was generally you've got some kind of scheme for passing correlation IDs through a chain of service calls. That's one kind of correlation, but the kind of correlation that Serilog is built for is the kind of chaotic correlation that you need to do when you're dealing with large systems that interact with each other in kind of arbitrary ways. Like, it might be feasible in a V1 to kind of roll out some kind of sophisticated pre-baked correlation scheme, but really when it comes to doing diagnostics and analysis, the number of scenarios for tracking down events are really kind of boundless. And so the kind of correlation Serilog is built for is to be able to go and say, without having thought about the scenario in advance necessarily, go and find all of the events from the same customer or the same order or the same subscription ID. And that this process of like natural correlation is really navigating through a stream of logs, jumping from one sort of correlation axis to another. You might have a request ID that tags everything that's generated by the same HTTP request. And in the back end, where you're processing orders, perhaps in a system, you might have a message ID that is associated with all of the events that come out of processing some kind of message bus message. And then, given the request that, or given the message handler that failed, can you work back to the web request that triggered it off? And that's usually a process of navigating back up through, say, some kind of natural correlation identifier in the one kind of timeline of the code, zipping across and then finding the other correlation identifier and working through all of the events there. And so Serilog is really a toolkit, I guess, for adding this kind of data to events. And it's not a completely foreign concept in .NET logging. Like there's generally some context. There's some kind of diagnostic context that you can jam data into in just about every logging library. But Serilog sort of treats it as a first-class citizen. You're not just kind of formatting a thread ID into the message. Log events in Serilog are like an event object, and there are a number of APIs that allow you to actually attach properties to that event, and you can then go and collect them up and use them for debugging later on. So that process we call enrichment. I've got a little demo. I'll make sure I actually set it this time. Okay, and so yeah, this one's writing to two destinations. You see, if you like AutoFact's kind of fluent builder syntax, you'll be really at home with Serilog. But you can chain that together, so you've got the console output and seek output, or file or database or anything else. So in this case, we've got a simple little program. It calculates an answer. The answer is the square of whatever numbers that we've gone through in the 0 to 99. And initially, all of those events are just going to actually get rid of that. Sorry, actually, wrong one. All of those events are just going to have the data that's provided in the message template. The first way, though, that we might want to drill down to a particular set of related events, especially if we're collecting a lot of events from some kind of service-oriented architecture or a lot of different applications, is just to attach some data at the at the logger level. So every event that goes through the Serilog pipeline, we might enrich it with a property called environment, and this one is going to be production. Should be demo, I guess. And so that's the simplest form of enrichment in Serilog. You can create we run that again, and if we look at the events, they will all have that environment attached there, and we can go and search or exclude, in whatever data store that we're using to collect the events there. The second kind of enrichment is probably the more familiar one if you're working with other logging libraries, and that is there's some ambient data that we can collect and attach to log events. So it's not always the same, but for example, we might have a thread ID, and we want to be able to tell what events were kind of raised in the same logical context. So we do with, I have a bad feeling I don't have the NuGet package installed. Really? Come on, ReSharper. Okay. Actually, we're going to have to skip that one because, terribly, it's not already in my cache and I don't have Internet on. We'll come back to that, though. So enriching the events with a thread ID will go and take the current thread ID that's like thread.current thread.manage thread ID and stick that onto each event object so that you can go and find events based on the same kind of causal chain. So those are the kind of the simple global enrichment scenarios, but that obviously in a single application you might have hundreds of different ways that you might want to go and track down events, and Serilog provides a much more fine-grained way of doing that based on the log context. And so the log context is Serilog's kind of scoping mechanism, and in every instance where we go through this loop and we calculate the answer based on whatever the current loop counter is, we might want to attach that to all of the events that are raised in the loop. So log context dot push property, and in this case we're going to say we'll call it counter because we haven't used that one in this example, and the counter is I. And here's where one of Serilog's design points becomes a little bit of an anti-feature in some way. If you look at the events now that come out here, you'll find that they don't carry our counter. Unfortunately, we also don't see the debug level events, so I should turn those on. So the reason that we don't see the counter is that Serilog really does stick to that no static state rule. Like, I do really like the convenience of like being able to put something in an ambient context and then have it just attached to stuff down the track wherever the call chain leads. But obviously, there's a lot of scenarios for doing logging, and so having a logging pipeline that goes and grabs data from somewhere by default just has a bit of a smell to me. And so we need to actually opt in and say enrich from log context. We run that again, and we now see that each time through the loop, all of the three events that are raised in the same loop iteration will have the same counter value. So if we find that, we'll see that we can now see that when the counter was 95, we produced the answer 9025. And so this is the enrichment technique that you would generally use, where you've got a message handler and the message came in and it's got an order ID attached. So you push that onto the log context and then make a bunch of logging calls that record how the order was processed. And then later on, if you've got a problem with it, you can go and follow along that chain and see everything that contributed to the same order being processed. All right. Okay. We were looking at the enrichment toolkit. Do we have a... Oops, sorry. I flipped the wrong way. Actually, I skipped one as well. So there is one other technique. It's actually I only include it because if you've used Log4Net, you're generally... All logging is kind of like source-oriented. So before I can log anything, I need to actually say which class is going to do the logging. And Serilog doesn't throw that concept away at all. For Serilog, we can actually create loggers, individual loggers that have enrichment applied to them. So we can say this is program logger equals log for context, and then program, which I hope is not static, because otherwise C# dislikes that. Very good. And in this case, we can say program logger.debug, calculating, whatever that is. And in this case, only the events raised by that one specific logger instance called program logger will carry that information. So this is the this is the inverse of kind of the I want everything in a call chain to carry the same correlation IDs. In this case, it's like I only want the messages raised by a particular logger instance to carry this information. So you can see we've got the source context attached to that calculating event, but we don't really have it on any of the others in there. So Serilog's got a fairly kind of complex set of enrichment APIs, but under the hood, these are all represented by the same concept. And this is where, if you've used middleware in, say, ASP.NET Core or Owen, that idea that you have a component that you can plug into the pipeline and can inspect all of the events that flow through the pipeline and interact with them is kind of a pretty good analogy for how enrichers work in Serilog. So with just this one implementation, you can implement ilog event enricher, and the parameters to that are the log event itself, and you can inspect the log event and look at all of its properties. And then you can not only add properties to the event, but you can remove properties as well. And this is where things get interesting, because there are a few different schemes where, for instance, you might want to log a user object, but not the password that we're storing as a text field attached to a property. Or maybe we want to make sure that there are no credit card numbers ever logged through the logging pipeline, and we can just inspect individual properties and wipe them out if they look like they might be a credit card number. So enrichers are a really powerful concept, and we use them for all kinds of things. It probably looks a little bit more complex than it needs to be. You see that we're passing a scalar value through here as the parameter instead of just an integer thread ID. And I think at least some of you will at this point be saying, well, how can this be a good idea? I've got all of these complex objects in my program, and I'm passing them into a logging library that's going to go and muck around with them on background threads and all the rest. How's that ever going to be thread safe? Serilog has a really limited set of types that it will treat as thread safe kind of scalar data, like it'll treat the built-in numeric types and strings and a couple of others that are known to be immutable. And then the other data that gets passed through, whether it's serialized or not, it gets pulled apart through a capturing process and put into an object model much like JSON.NET. So if you've ever used JObject and JArray and those types in JSON.NET, Serilog has structure value, scalar value, and some equivalent types that are used to represent the actual log data. So the enricher here actually has to use a scalar value to represent the thread ID, just to say that's how this thing's represented. Otherwise, it will end up getting converted using toString, because that's the way that Serilog determines that something, or ensures that something is going to be safe to go and pass through an asynchronous logging pipeline. So more than meets the eye. So Serilog is based on a pipeline as well that you can see on the left there. Enrichers kind of go right in the middle, and then using that same pipeline, we can plug in filters and lots of other kind of event-oriented concepts. And the pipeline kind of looks like it's a fixed topology, but you can chain pipelines together, do all kinds of event processing type things, like you can send the output of a logging pipeline to Rx, and then do some kind of analysis for, say, windowing or otherwise, like rate limiting, and then pass the events into another logging pipeline that might dispatch to sinks. So it's not really enrichment that's the fundamental idea here, but the notion that logging is an event pipeline rather than being a kind of a big text formatting engine. So that's really Serilog in a nutshell. There's a lot more to it, obviously, if you want to get in there and learn about how its APIs work. But if you focus on how message templates make it possible to do human-friendly as well as machine-friendly logging without extra overhead, and enrichers make it possible to handle the kind of microservice architecture that you wrote last summer and now you're lumped with supporting. And those two things, I think, are the reasons that you use Serilog. So you can find Serilog at serilog.net. That's me up the top there. And there's the message templates.org that I mentioned. We're on GitHub. Seek that I showed is up there as well. I think we've got some time left for a few questions as well. And because I will forget, I have Serilog stickers. I have many Serilog stickers. So please come and see me if you would like to grab one of those as well. So can I take any questions? Yeah, over there.
Do you have something opposite of the enricher? See if you want to make sure that sensitive information like social security
Okay, yeah, so the question was whether there's a way to do the opposite of enrichment, which is kind of remove sensitive information. So the same interface is used for that process. So if we zip back to the example enricher, you see it has the add property if absent method used to modify the log event. We jump through a few hoops because we want to minimize the number of dictionaries we allocate when we use thread-safe data structures. So add property if absent seems pretty wordy, but that just adds a property. There's another one called remove property if present that can do that kind of work. And I didn't show it in any of the demos, but the capturing process for Serilog is also pluggable. So by default, you can use the little @ symbol to serialize a .NET object just by walking its properties. You can plug in what we call destructuring policies. There's a long story about how that name came to be. And they will actually also let you customize how objects are pulled apart. And so we have a destructuring policy that handles F# types. We have policies that handle things like JSON.NET dynamic objects, and we can serialize those into Serilog data. And that's also where we have a library that allows you to mark sensitive properties with an attribute. So that, say, if you've got an SSN property on a DTO, you can put an attribute not logged on there, and the policy will make sure that's excluded at the time that the object's captured. Sorry, yeah.
What's the strategy for network-based loggers if the network is down?
The sync infrastructure that actually sends messages out to destinations is really free of any kind of like overarching policy. Like you just plug in an interface and you give an event to the thing and it can do whatever it likes. There's a pre-built sync abstract base class called periodic batching sync, which will go and batch up messages and then allow the derived sync to go and send them, say, to some network destination. And the built-in one has a policy that does an exponential backoff where if the attempt to log fails, it'll wait for twice the timeout and then 4 times the timeout and get up to about 10 minutes and then start dropping events on the floor. So Serilog, I really didn't want to deviate far from what I knew and loved in Log4net because, I mean, it's been a successful strategy for me. And Log4net has that kind of fail-stop policy where nothing in the logging pipeline will bring your application down. And in Serilog, not only we don't propagate errors back out from network calls, we also try to make sure that we don't keep too much data in memory either. So there's a little bit of stuff in there, but you can customize it by plugging in wrappers as well that might wrap up a sync in a different error handling policy. There's quite a few options. Does that answer your question? Yeah, great, thanks. Yeah.
Will it be possible to enrich an event that's already been sent?
You could, and it wouldn't go anywhere. Yeah. So if the event's already been sent.
No, I mean, the event already happened. Let's say we have a couple of logs that apply to a certain order with a certain order ID. A couple of stuff happens, then the order gets fetched, and only then we know the order ID. Would it be possible to apply that order ID to the queue if it already happened?
Okay, so the question was if, say, something like an order ID was only revealed after a few related events had already been processed, could that be retrospectively applied to the earlier events? It may be possible if you did something custom in the sync infrastructure. There's an idea that has been floated a few times called kind of transactional logging, where we buffer log events as we go at the debug level, say, and we just throw them away unless an error happens, in which case we flush the whole lot through. Serilog doesn't implement that. The trick to implement what you're suggesting right now would just be to come up with, say, some kind of GUID operation ID, and then you would log that on all of the related events and use the order ID to surf backwards towards the built-in the operation ID, perhaps. Okay. Yeah. Cool. Great. Sorry. Yeah.
I've observed over many years that the complexity and size of logging systems tends to increase until it reaches the same order of magnitude as the system being logged.
Yeah.
So does the probability of errors goes up.
This is
Sounds
sorry.
familiar?
Yeah. This is one of the core things that I think drove me to start working on Serilog, and it's gotten stronger over the course of. We went through the .NET Core shift that everybody else I think has gone through in the .NET library space, and we really pared down the core of Serilog in that process. The core Serilog DLL has only got a few types for handling the kind of destructuring, capturing kind of enrichment things. And we've tried to keep things like the file-based syncs, which tend to grow until they become less complex as databases, in separate packages. And there are, I think, in all these cases, we've tried to keep options open so that rather than try and make one set of syncs do everything, we try and keep them simple enough that if someone wants the file logger to do something we don't do, they could, if they're prepared to spend the effort, just go and fork it and create an alternative, and there's only a small amount of code for them to have to modify. But yeah, I've seen that phenomenon too. It's a pretty strong guiding principle for how we organize the project, because I see that the trajectory of logging libraries does tend to really slow as they start to get more complex. Yeah, but thanks for the question. That's an interesting observation too. Yeah, and over here.
We're currently struggling to include the class name and line number. Is there any? I mean, it's such a common problem.
Class name and line number are very hard to. There is a way to do it. In fact, if I have a chance to chat to you after this, I can sketch some code. It requires you to do a little bit of extra work each time you write a log statement, though. But yeah, there is a trick for doing it. Unfortunately, with C#, you can choose either to have a variable number of arguments, or you can choose to get the class name and line number passed through to a method. And so Serilog, like many others, chooses the variable number of arguments in it. But it's been raised a few times, and there is a hack for making it work. So I'd be happy to help with that one. Any other questions? We have some time. Yeah.
What's the performance like compared to, say, Log4j?
At least as good. Yeah. I mean, Serilog has been built with. It puts the quality of the log data first, and then when it comes to performance, the biggest focus we have on performance is performance when the logger is turned off, because that's probably the most critical performance, where you have, say, a debug statement in a tight loop, and you turn that off at runtime. And we try very hard not only to make sure that that's as close to zero allocations as possible, and generally we do have zero allocations on that case. But we also do things like we don't use volatiles or memory barriers by default, so logging statements where the logger is off don't have any impact on a CPU cache, that kind of thing. So logging with Serilog off is about as fast as it gets. We allocate a bit more as far as the event objects that go through the pipeline than other libraries, but once you start to really use any existing logging library to try to include correlation information, that enrichment sort of scenario, you end up having to allocate things like a dictionary to hold them. We've got some more room to optimize in the future and some ideas, though, so we're at least as good as anything in the space at the moment, and I think we've got room to go better. Definitely the intention. Yeah, Josh.
Yeah, what happens if you forget your password for your Seek server?
Oh, yeah. I just format it and start all over again. Sorry, yeah.
You said there are hundreds of syncs. How many of those are under
The Serilog project?
Project itself, and how many of those are named third-party developers?
Yeah, under the Serilog project, I think there are about 50, somewhere close to about 50, and the rest, it's hard to track them all down, but yeah, there are a lot produced by people outside the project. I think we have time for one more, potentially. No? All good? Okay, thanks. You guys have been an awesome audience. Thanks for coming along. Really appreciate you taking the time to come and say hi. Thanks. And